is a blast from the past, literally 32 years ago. This talk is about generating HP-41 regression programs based on William Kolb's book that he published in 1982, titled Curve Fitting for Programmable Calculators. Bill Kolb was a PPC member, attended a lot of the conferences then, and he wrote this book for the 41C programmer. And the book is very interesting. I was looking at it about a month ago, and indeed he presents a wide and comprehensive set of regression models from stuff that we typically use. It includes also curve fitting for probability distribution functions and so on. Bill used an interesting approach that to be able to do best curve fit without forcing you to re-enter the data more than once, he used a unified scheme to store statistical summations for different variables and for different transformations, pretty much throughout the 99, almost the whole registers of the calculators. And in his book, each chapter would introduce the curve, the type of curve he's doing, would introduce, show you the registers he's using and what summations they're tracking. And then he would give you a formula to calculate the slope, intercept, and other regression coefficients and the coefficient of determination for that model. But he did it in a very special way. Instead of using statistical summations like most books, including HP stat books, he would use the register numbers. So in a way, he made it a little bit easier to take that information and code it into a program. I got interested in the programs he wrote for multiple linear regression for 2 and 3 independent variables. But I did not want to use his register numbering scheme. I think he said like 16 in register 69, 70, 65, something like that, in the middle of the memory map. I'm like, what if I want to bring all these registers down to, say, 1 and start from 1? So I decided, well, let me write an Excel application with using Visual Basic Applications Edition and have it do the work for me. Initially, I started by, my first run was to translate his equations. And indeed, it would write the equations in terms of the registers. I would give it my registers for the summations that he's mentioning, and would just translate them. And then I realized this was dumb. I still have to code the thing. Why don't I let VBA do the coding for me? Of course, since there's no magic in all these things, I had to do some tricks, which is basically write a compressed version of an entire program, and then have the VBA Excel subroutines work on it. I decided, for the sake of completeness, to include linear regression and polynomial regression, loosely or closely based on Bill's code. Here's a typical worksheet. What you will have in the proceedings is an Excel file, and there are 11 worksheets, and I will explain how they're divided. But a typical worksheet, and I used consistent interface so you don't get confused, has several columns. The first column lists the names of the variables in the program, starting with the summations, also the covariance coefficients, then the regression coefficients, coefficient of determination here, its adjusted value, especially if you're using multiple terms, so you can compare different models having different terms. And then the variables here. You can see like temporary variables I use in case I use transformation, or I take into account that you may want to do transformation, so there's space for that, and some extra variables. So This list is complete of all the variables in the program, not just the ones Bill Kolb mentioned in his book, because I needed to generate a complete program. The second column contains the register index that I or you want to use. Now notice, for example, here, now they go 1, 1, 2, 3, and all that. Here we have 16, 17, 18, and then notice I reuse 16, 17, 18. So they don't have to be unique. It's just when you use them, there is no conflict of use. Because, for example, when I'm entering data, I can use these registers, and by the time I start calculating the regression coefficients, I no longer need these anymore because all their information has been passed on in the summation register. So I can go ahead and reuse some of these registers. So make sure that when you're using the duplicate names, that there's no the scope of the variables you're using are separated. Third column is just labeling the model. Fourth column says the model number, which the VBA code uses in creating a documented HP-41C program. Tells you what the model is. This is your output file. And then this is a flag that says if you want to include comments. I've included some comments because when I was reading the 41C code, there was just hundreds of lines and like, where am I? And so you can include the comments or not. If you exclude them, that will help you then cut and paste the 41C source code and then compile it into .raw file. Well, good news, I did that for you, so you really get everything. You get .raw files that you can quickly load in 41C emulators and run it without typing a single command. And this is, I'm explaining the various columns. The Excel workbook has 11 worksheets divided into 4 groups. The first group deals with linear regression, and there are 3 worksheets. The one labeled LR handles general linear regression. It's just general. Now, if you look at the code, there's label 00 that allows you to include your own custom transformation, whatever you want. The LR2 worksheet handles a special regression model that I've used in on HP Solve articles. Oh no, I got it. Here one. That use a special model where I raise both variables x and y to some powers. Now these powers could be positive, negative, as long as you don't get into trouble generating runtime errors, and 0. And 0 is interpreted as a request to calculate the natural log. So if you supply zeros here, you're doing basically a power fit, which is done for you here in the LR3 worksheet. It handles power fit, where it translates the variables into their natural log before processing them. The second set is where I start really tapping into Bill Kolb's equations and code, summation registers in his code, and it does multiple linear regression for 2 independent variables. Worksheet MLR2 handles the general case. Again, label 00 allows you to specify the transformation where you take the raw input, transform it, and store it in another variable that handles that's used in the summations. Again, MLR22 is the spreadsheet that handles the special case for using the model with powers. So here I have x, y, and z raised to 3 distinct powers. The same rules that I mentioned for the linear regression, the powers apply here. They can be negative, positive, 0, meaning you want the natural log. And if you want to use a multiple power fit, then MLR 2.3 worksheet will handle that for you. It will included in the code is it takes the natural log of all the variables. They all have to be positive, so you don't get in trouble. The third set of worksheets handles multiple linear regression for 3 independent variables. This was the reason I really got interested, because when I look at the stat pack of the 65 and 67, I do see equations for 2 independent variables, and I've used those over the years. But when Bill Kolb showed me how to do 3 independent variables, that got me thinking like, because it's more complicated, had more equations, the calculations is longer. Again, there are 3 worksheets. MLR3 handles the general case. Label 00 allows you to do the custom transformations for yourself. MLR32 is the case where we raise each variable to a power, and the same rules I mentioned before apply here. And finally, MLR33 handles a multiple power fit where all 4 variables in the model are transformed into their natural log. Yes?
You mentioned XYZT. Is that mapped to the stack registers also? The data, or
actually, yes. When it prompts you, it'll say enter T, Z, Y, and yeah, it's a happy marriage.
Okay.
The last set of worksheets handled the polynomial regression between only 2 variables, x and y. You have a worksheet poly 2 that handles a quadratic regression, and this is loosely or actually closely based on MLR2. I just did some little tweaking to use the code for multiple linear regression by eliminating y because it's really x squared. And poly 3 handles cubic regression, and again it's based on the multiple regression for 3 independent variables. Now the code, each worksheet has a macro whose name starts with make41 program, and then the X's here are the name of the worksheet, so you don't have the same subroutine name repeated, and then you get in trouble. It has meta code or compressed code because really there's no way around generating magically HP-41 code unless it's the programs, complete programs, unless they're stored somewhere else. So I basically, each worksheet has a condensed version of the program that's stored in. And it uses multiple statements to build these metacode before translating them into readable program. The subroutine first build an array of records, and each record stores the name of the variable, the new index, register index, that's the one you saw in the spreadsheet that you specify, and then the registers that appeared in Kolb's book. Now, of course, because I have to write a complete program, I had to add Kolb-like indices or a la Kolb indices to make it more complete. The program uses a string variable listing to build the program, and instead of being vertical as we're used to, it's actually horizontal. So I needed to, the statements are separated by comma, which had actually some advantages. And because I'm doing linear regression using a lot of store and recall, I decided to make those strings shorter, use the letter S, R, and A as abbreviations for store, recall, and alpha recall, because I'm pulling the results to display to you in the alpha register. So, like I said, in many cases, the VBA uses the register indices from Kolb's book. I added some more for the sake of completeness. Now, if you want to use store or recall stuff in the stack, you have to put the command as it is. There's no abbreviation. It will not work. The abbreviation was meant for like S and then the Kolb register index, and it'll say, okay, it's store or store plus or whatever. You can insert comments. The comments really are separate programming steps because they must obey the comma separation rule. And it starts with the pound sign, and then has the text, and then ends with a comma. Starts with a comma, pound sign, the text. And it should appear right after the statement it comments. So it's going to appear in the output as the VBA code will put 2 tab characters and then put the comment, so it all appears a little bit flushed to the right after that statement. Alpha strings start with single quotes because VBA uses double quotes to store strings, and a closing single quote is optional because since you're separating statements by commas and it's splitting all the commands into an array of, using the comma, you don't have to put the closing single quote. Now to append characters, you put the vertical bar followed by a dash and then a single quote to append the text. Again, a closing quote is optional. Now labels go to statements and execute statements that use alphanumeric labels must have these names begin with a single quote and end with the ending a single quote is optional. Now I actually only use this in the program typically once when the very first statement is the HP-41C program name and has double quotes. The code in the VBA does not use these, but it's there in case if you want to do a little bit of transformations or whatever. The mapping between the shorthand or metacode to the 41 is not complete. I added few things more just in case, being thoughtful. Other than that, all other 41C commands must appear in their normal name and syntax. User interface. All the programs, all 11 types of programs generated by the VBA code have the same user interface. That would make it very simple. Once you load the program, you hit Shift A, and it clears all the registers. I initially was storing zeros in the individual registers, and I was like, slow, and then error prone, so just clear all registers. Because basically, the program is taking a sizable amount of memory, especially when you're running multiple regression with 2-3 variables. In the case of the subroutines that use the power model, they will prompt you for the powers for the variables when you initialize, when you zero the register. After you zero the register, it'll say, give me the power for X, for Y, and so on. And you type these in once. To add the data point, you press A, and it'll prompt you for the variables. You type them in, hit run, stop, and you're good. Now, to delete data, you hit the B button, and it will prompt you for the values you want to delete. Now, if you want to delete data you just entered, like you enter the stuff and you're like, oh, I just messed up, well, hit Shift B, and it will automatically delete the last set. The program uses flag 0 to track that so that you don't accidentally start deleting the same data that did not make sense, and I put it as a precaution. Now, once you're done, hit the C. You have to be, of course, in user mode. Hit the C button, and it'll start doing the calculations. It'll calculate the regression coefficients, coefficient of the determination, and its adjusted value, and then display the results in the alpha register, and hit run, stop, and to go through the results. If you want to review these results, shift key C, and you get to see the results again. The output is pretty much based on what you see in the worksheet. It will list the regression model as written in the worksheet. You will see the memory map as it appears in the worksheet, but it's in reverse. It will use like R, the indices number that equals the name of the variable. So you have a map, and it's really, even in debugging when I was developing this last week, it was handy to be able to look at the generated code and what the registers meant. So that was good. And then there's the 41C listing, commented or non-commented. It's up to you in text mode. And that's it. So we're good.
Any questions for Namir? What's the 41?
Is that 42 minus 1?
Yeah.
Okay,